Hello everyone, and welcome to this first recording on basic concepts. So the sections that are going to be covered in this recording are as follows. We're going to take a look at the introduction to electric circuits and standard SI units. We're going to look at charge and current. We're going to look at voltage, polarity and passive sign convention. And then finally, we're going to look at power and energy. So what is an electric circuit? An electric circuit is a connection of electrical elements. So as can be seen in the diagram below, we have a load, which is the lamp, and we have a source, which is the battery. So the battery provides energy in the form of voltage and current to the load, which is the lamp. And current will therefore flow in a passive sign convention direction, resulting in power being dissipated and energy being used over time through the load, which is the lamp. So what are the different circuit elements that we're going to be working with? The first is the resistor, and this is the circuit symbol for a resistor. It is measured. The value of resistance is measured in ohms, and this is the symbol. Second is the capacitor. So this is the circuit symbol for the capacitor. Capacitance is measured in farads, and the unit will be F. We also have the inductor. The inductance is measured in henries, and the circuit symbol for that is H. We have voltage sources, in particular independent voltage sources. So this is an independent voltage source. It will be the voltage of the independent voltage source will be indicated in volts. And then we have the independent current source, and the independent current source will also have a value in a unit, and the unit is amperes. So the value that you obtain, or that is given for the current source, will be in amps. In addition to this, we also have dependent sources. So these are voltage and current sources that are dependent on some value within the circuit. So you have a voltage dependent voltage source, you've got a current dependent voltage source, you've got a current dependent current source, and you've got a voltage dependent current source. An example of this, a voltage dependent voltage source would be a source. So it's a voltage source whose value will be dependent on voltage. So the value would be 2Vx, where Vx will be some voltage within the circuit. A current dependent voltage source is a similar circuit where this value will no longer be 2Vx, but it will be dependent on some current in the circuit. So that would be 2Ix, for example. And then your current sources, so your dependent current source will take the shape of the diamond and an arrow, and a current dependent current source will have a value that's current dependent, so let's call this 5IV, and a voltage dependent current source will be dependent on voltage, so it will carry a value of, let's say, 10Vx. And this is the dependent sources. Now, when considering SI units, the foundation of this section was based on the fact that measurements and calculations must be communicated in a standard language that everyone understands. Hence was the formulation of the International System of Units, or SI units. So this was adopted in 1960 and has 6 standard units as well as prefixes. Let's take a look at these units and prefixes. So we'll see here that the 6 standard units and prefixes are length, mass, time, electric current, dynamic temperature, or rather thermodynamic temperature, luminous intensity, and charge. And the basic unit for these are given in the column in the middle. So that will be length in meters, mass in kilograms, time in seconds, electric current in amps, the temperature in Kelvin, luminous intensity in candela, and charge in coulombs. And the symbols are given in the last column. Further to this is the SI prefixes. And these are linked with multipliers for one to be able to give the original symbols in a presentable way. Right, so you've got multipliers that range from 10 to the negative 18, which is atto, to 10 to the 18, which is exa. Right, and in between that will then be prefixes that you can use. For example, 10 to the power 1 will be given as deca, 10 to the power 2 is given as hecto, 10 to the power 3 is given as kilo, for example, kilogram, 10 to the power 6 is given as mega, 10 to the power 9 giga, 10 to the power 12 tera, 10 to the minus 3 milli, micro is 10 to the negative 6, nano is 10 to the negative 9, and pico is 10 to the negative 12, etc. Let's take a look at an SI unit example. So if they were to ask a question that says determine the current flowing through an electric circuit, and you found that the current is equals to 0,002 amperes, right? This value can then be represented by using a prefix that will get it to a unit that's more presentable. And what we can do there is we can multiply this by 1,000 to get it to milli, so to the prefix of 10 to the minus 3. So we want to get it to this particular prefix. All right, so if we multiply that by 1,000, we should get that the current is equals to 2 milliamps. So this will be 2 times 10 to the negative 3 amps. This is an example of an SI unit. If you were to measure mass, which we know is in kilograms, and what you found for the mass was this was given as 6,150,000 kilograms, then we can also convert this. We can multiply it by if we multiply it by 1,000, it will be 1, 2, 3. Multiply by another 1,000, 1, 2, 3. So we can say this is 6,15 times 10 to the power 6 kilograms. And that should give us and you can see here, if you give it in grams, right, you would have to say this is now 6,15 multiplied by, because kilograms is already 10 to the power 3, so this will be times 10 to the power 9 grams. So that can be given as 6,15, and then what is 10 to the power 9? You'll see that it's giga. So that will be gigagrams. Right, and this is how you would be converting from one SI unit to another. Thank you for watching this video and enjoy the course.